Okay, quadratic-in-form equations. All right, so the objective for this video lecture, let's solve equations that are quadratic in form. And of course, we're going to have to define what quadratic in form means. But first, what do we know? Okay, we know what a quadratic equation is. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0. And that's called the standard form, as we know from previous video lectures, where a, b, and c, the coefficients of the x terms, in this case the constant, are real numbers, and of course a does not equal 0 because you have to have a squared term in order for it to be a quadratic. Now we've learned that four ways to solve quadratics. They can be solved by factoring. They can be solved using square roots. They can be solved by completing the square, and they can be solved using the quadratic formula. Of course, some of these only work for some quadratics. Factoring or using square roots only work for some quadratics. Completing the square and using the quadratic formula work for all quadratics. All right, so what does quadratic in form mean? What is a quadratic in form equation? Well, it's a quadratic equation, and we're going to use u in this case. So au squared plus bu plus c equals 0. And of course, the coefficient of the squared term cannot equal 0. However, the u represents here an expression that involves the letter x. Okay? So a little complicated. Let's take a look at an example. So here's an equation, okay? And you can see the quantity x plus 2 squared plus 11 times the quantity x plus 2 minus 12 equals 0. Solve that for x. Well, kind of good luck, right? How do you do that? Okay, well, if you'll notice, okay, we have something squared plus 11 times the same thing minus 12. So if we let u equal x plus 2, we can rewrite. If u is x plus 2, then this is x plus 2 squared becomes u squared. X plus 2 squared, but x plus 2 equals u, so that's u squared. Okay, plus 11. Well, 11 times x plus 2, well, if x plus 2 is u, this is 11 times u. And then, of course, minus 12 equals 0. And if you look at this one, you say, wait a second, that's a quadratic. This one, I can solve this one. I can solve it by factoring. Okay, that's a pretty straightforward quadratic. Way easier to solve than whatever this is. So this one is called a quadratic in form. Okay? U represents an expression that involves x. So we can solve this. We can kind of substitute and let u equal something, solve the simpler quadratic, and then go back and figure out what x is in the more complicated equation that can be written as a quadratic. Okay, so let's do a couple of examples. Let's do this example. The quantity x plus 2 squared plus 11 times the quantity x plus 2 minus 12 equals 0. Okay, so as I said, let's erase and put example 1 here. So example 1. Let's solve this. Okay, sorry, my paper is a little bit written on. Let's solve this. Okay, let's solve this equation, the quantity x plus 2 squared plus 11 times the quantity x plus 2 minus 12 equals 0. Okay, well, let's rewrite this as a quadratic in form by letting u equal x plus 2. Okay, so let u equal x plus 2, the equation becomes, as we saw before, u squared plus 11 times u minus 12 equals 0. Okay? Now, again, this is a quadratic. It's set equal to 0. We can solve it. Usually when I see something like this, the question is it factorable? Let's see here. We need a product, the product of negative 12, and we need a sum of positive 11. Well, 12 is 1 times 12, 2 times 6, 3 times 4. If I do a positive 12 and a negative 1, positive 12 times negative 1 is negative 12. Positive 12 plus negative 1 is positive 11. So I can factor this as u plus 12 times u minus 1 equals 0. Okay, so now we know if this quantity is 0, then the answer, the product, is 0. If this quantity is 0, then this product is 0. So we have two possibilities. U plus 12 equals 0, or u minus 1 equals 0. And this is pretty straightforward. Let's subtract 12 from both sides in this case. And I get u equals negative 12. And let's add 1 to both sides in this case. And I get u is equal to 1. Now careful. Students will stop here. They've done all this work. They've got negative 12 and positive 1. And those are the solutions. Not yet. And here's the reason. Let's go back to the original equation. The original equation was the equation in x. What does x equal? Okay. Telling me what u equals is not getting me anywhere. Okay, it's not the answer. We want to know what does x equal. So we have to go back and we have to remember, hey, we were told that we set up here that u is equal to x plus 2. Okay, excuse me, x plus, I wrote down 12 and I said 2. U is equal to x plus 2. Okay, so we have a u equals negative 12. So we have negative 12 equals x plus 2. Okay, again, here's the negative 12 coming down and substituting for u. Or we have 1 equals x plus 2. Give me a second, my pencil is running out of lead. There we go. Okay, and again, here's the positive 1. If u equals x plus 2, then positive 1 equals x plus 2. Now I can solve for x. Subtract 2. On the left equation, I have negative 12 minus 2 is negative 14. The right equation, again, I subtract 2, and I have x is equal to negative 1. So here's what x is equal to, or so I think. Okay, you need to solve, again, the question was in x, in terms of x. Your answers need to be in terms of x. Okay, let's check this by graphing. Okay, let's go up to here. And it's already, this equation is equal to 0, so we're looking for roots. We're looking for x-intercepts. Okay, so we're going to put in y equals. And we're going to, let me see something. Let me make sure I'm in a, let's go to here. Okay, I'm going to go to my standard window. Whoops. Something happened. It's waiting on something. Uh-oh, I did something and it wants to pause a bit. Okay, let's go back. Turn it on. Okay, let's go to y equals. Here we go. Okay, parenthesis x plus 2, close parenthesis squared, plus 11 times x plus 2, minus 12. So there's the left side expression. It's equal to 0, so I can just leave it alone. I'm looking for x-intercepts. Let's graph. Here we go. Okay, looks like I've got part of a graph. Let's zoom out. I'm going to change my window. This is the standard window from negative 10 to 10 on both the axes. Let's go from negative 20 to 20. I'm just playing. I don't want to zoom out a whole lot. I want to zoom out a little bit and see what happens. Oh, there we go. So now I can see there are two places where this graph crosses the x-axis. Let's see what they are. So I'm going to go to Calc, and I want to calc my zeros. And I want to first check this left one over here. So let's move my cursor over and set my left bound. Just going to hold down the arrow and get over there. Okay, that's pretty good. That's my left bound. Let's do my right bound, is down below. Look in between those two, and I came up with, whoop, there's negative 14 right there. Negative 14 is where that crosses the x-axis. I go back to here and I notice negative 14 was what I came up with algebraically. So I feel pretty good about that one. Let's see if the other one is negative 1. Okay, so let's go back and let's calc the other one. It's 0. And let's go to the left bound over here below the axis and the right bound above the x-axis. So in between those two lines, and let's take a guess. Yep, I got negative 1 right there. So, and here's my negative 1 down here. So I feel pretty good about that. Those two answers look like they work pretty well. Okay, let's look at a more complicated example that's going to involve using the quadratic formula. Okay, so let's see here. Example 2. Okay, so I shouldn't say it's not a whole lot more complicated, but a little bit more. We'll use the formula, a little bit more work involved because using the formula. Okay, minus 1 equals 0. We want to solve this. Okay, well, it's not a quadratic because that's the fourth term. I think it's called a quartic. Hope that's right. But it's not a quadratic. However, you'll notice that if I take this and I square it, I get this. Okay? So it helps to kind of look at the x, what's the second term, the x term. If I square what's here, do I get what's here? If that's the case, I have a chance for a quadratic in form. Okay? So let's take a look. How about if, let's let u equal x squared. Okay? If u equals x squared, then the result is we have 3 times u squared, because x squared is x to the fourth. Okay, minus 2. Well, if u equals x squared, this is minus 2u. Minus 1. Ha! That's a quadratic I can solve. Okay, now I'm going to notice I have a 3 here, not a 1. Factoring could be a problem. I'm going to go with the quadratic formula. So let's note my A, my B, and my C. A is plus 3. B is negative 2. And C is negative 1. Okay, so now I'm in U. I'm in U world, if you will. So let's use U. U is equal to opposite B plus or minus square root b squared minus 4ac all over 2a. Let's substitute. Opposite b. B is negative 2. Don't lose the negative. That's where things get lost right there. Plus or minus square root. Okay, parentheses, b squared again. Don't lose the negative. B is negative 2. Minus 4 times a times c. A is 3. C is negative 1. I'm just substituting with parentheses. I'm doing no math otherwise. 2 times positive 3. 2 times a. Okay? Well, this is 2. Plus or minus. This is the square root. What do we get here? Okay, I can use my calculator here if I want. Oh, let's do that. Let's use my calculator. Think I'm in there? I'm just going to do the determinant, what's underneath here. So, let's see here. Negative 2 squared minus 4 times 3 times negative 1. I get positive 16 came out of that. Okay, that's pretty good. 16. That worked out well. All over 6. Okay, well, of course, this is 4. So I get u is equal to 2 plus or minus 4 over 6. Okay, so u equals 2 plus 4 over 6. Well, 2 plus 4 is 6 over 6 is 1. Or u equals 2 minus 4 over 6. 2 minus 4 is negative 2. This becomes negative 1/3. Okay, so I solved for u. I got u equals 1 and u equals negative 1/3. Okay, so I went from the x land, if you will, using x. I substituted and I did some work using u. Don't forget, don't stop. Just because you got answers, but these answers are using u. The equation said solve for x. So we have to recognize, okay, we know. However, okay, we know that u equals x squared. So we have to go back into the x world. Okay, u equals x squared. So let's take our first u. So we have 1 equals x squared, or negative 1/3 equals x squared. Okay, so I had this u equals 1. This 1 is what came in and substituted for u. This negative 1/3 came in and substituted what's in for u. If u equals x squared, then 1 equals x squared, or negative 1/3 equals x squared. This one's not bad. Square root, square root, square root. Don't forget, plus or minus. So x equals positive or negative 1. Okay, this one, square root, square root. Wait a minute. In the real world, in the real number system, I cannot take the square root of a negative. And so we're only working, in this problem, we're only looking for real number solutions. So this one's not going to get me anywhere. Okay, I'm not going to throw eyes at you right now, although we've done some work with complex numbers. We want the real solutions in this case. This one's going nowhere. Okay, so that's not going to happen. Okay, nothing at all here to work with. So our two solutions are positive and negative 1. Again, in the real number system, negative 1 and positive 1 are two solutions. Okay, let's check it graphically again. Go back up to here. Okay, turn it on. Let's go back to y equals. Let's clear the previous one. So 3x to the 4th minus 2x squared minus 1. It's equal to 0. So we're looking for x-intercepts. We're looking for roots. We're looking for zeros. Let's graph it. Now remember, I'm in a negative 20 to 20 situation here. That looks pretty tight. Let's go back and let's make my window back to the standard window from negative 10. Whoop, I go to zoom. Let's go to standard. Okay, that's a little better, and I can see it crosses in two places, and it looks pretty clearly like it's negative 1 and 1. But let's check. So let's go to second calc. We're going to calculate the first 0, which is the one on the left. So I'll set my left bound for that one and my right bound, and I'll check it. And here's my 0 at negative 1. Well, that fits this one right here. Whoops, you can't see that. That fits this one right here. Okay, let's go back up to my equation, and let's check this other root, this other 0. So second calc, I want the 0, and I want my left bound, my right bound to be on either side of that x-intercept. And let's check that one. And I get positive 1 right there. And that's what I have right here. I'm good to go. So there you have it. Solving quadratic-in-form equations.